Hello, this is a tiny demo of the small programming language that I've been working on. Uh, so right now I have this little command line and we have a REPL that we can start. It's a very simple REPL, single line, doesn't have much. But for example, we have numbers, there's only floats right now, there's no ints. So 1 or 1.1 are a float. We have booleans, false and true. Right now they are lowercase, like in JavaScript languages, but in Elm-like languages they start with a capital F, like that. So I may change it in the future, given the language looks more like something like an ML than a JavaScript or C language. We have the unit type, which is kind of like a void or null. What else? We have strings. And you can see every time I write an expression, the type gets inferred. So you don't have to type annotations. We have, I think those are primitive types. We have parenthesized expressions, so you can have like one in parentheses or many parentheses if you want. There's function calls. In this case, this is going to be kind of dumb, but if the function calls are with spaces, so imagine one was a function, instead of doing that like in JavaScript, you use spaces. So in this case, it's a type error because it's trying to apply the number 2 to the function, this function, but this function is actually a number. So anyway, just something a bit confusing. Ignore it for now. We have we have if statements. So 1 equals to 2, then I don't know, hi, else, ho, and that's kind of a toString of the AST. It's not actually JavaScript. It could be runnable JavaScript, but it isn't right now. The if statements, like in Elm and those languages, you have to have an else branch. You can't have just an if, because everything's an expression. So we have some nice error messages as well for when you mistype things. Like for example, in this case, missing an else case on the if expression, or we don't close our parentheses. I tried to point to the beginning of the parentheses that wasn't closed. So that, imagine you didn't close a parenthesis or a brace, it will point at the start rather than at the end of the file, it happens sometimes in some languages. So it showed if statements, function calls. We have binary operators with precedence. So 1 plus 2, if we do 1 plus 2 divided by 5, this would actually be the precedence we need to be taken into account, right? Because if you do it naively, you do 1 plus 2 and then divide that by 5. But taking into account the precedence, you have to do 2 divided by 5 and then 1 plus 2. So this was quite interesting. I ended up using precedence climbing algorithm, but there's different kinds of things to do this kind of stuff. And that includes also that's the math. There's Boolean, like true and false. So I use and the or for readability, and I also have equal and bang equal for distinct. Those are the ligatures in my font, but it's it's a bang and an equal together. And they have the precedence property set. So if I say 1 equals 2 and 2 equals 3, it actually groups them appropriately. First it does the comparisons and then it does the Boolean operators. That was fun to figure out. And also have unary operators, so like -5 is the minus operator with the 5, and not false, it would be the Boolean unary operator, negation. And I also have let bindings and lambdas. So a lambda starts with a slash, like in Elm. It's kind of like a lambda symbol. If you imagine like a, something like this, just this slash. If you had the tiny poke here, it would be like a lambda. So this is lambda with an argument a, and then we're gonna do, whoops, we use a single arrow like in Elm, a plus 1. So it's a function that takes a float and returns a float. And this is a very naive toString. And so that's the lambdas and functions. You can have multiple parameters. So you can say A, B, C, and then add them up. For example, it's a function that takes 3 floats and returns a float. Functions are queried, like in Elm or Camel or all these other languages, so that you can do nice things. So for example, if we have this function, let me put a parenthesis, I have this function, then I could call it with only 2 of the arguments, for example 1 and 2, and that would give me a function that would take a float, which would be the last one, right? And then it would add it to 1 and 2, right? So it's like a partially applied function, right? Because all of the functions are queried. And we have let bindings, but I can't show them on the repo right now because they are let with the name of the variable and whatever you want to do. And then I need to do an enter. So because it's white space based. So I'm going to show that with the other feature of the compiler, which is the run command. So I have this file here. So I'm going to say let add is a lambda with a and b, and then I add them together, a plus b, and then down here I can say add 1 and 2, right? So I save this file and I run it, and this is the inferred type of the result, the last expression, and then the toString output. In the toString of the ASTA I'm using right now, just a string interpolation, right? So the function and the call. And yeah, I have type errors. So if I pass here false, this shouldn't compile even if I didn't write any types. And if I run it again, I have a nice error message. Bool is different from float. I expected this thing to be a float because of the add function, but it seems to be a bool. And the same things for, if I had 1 equals to false, for example, here, I don't know, something dumb, I'll get an error here that, there's an equal sign, so both things on the 2 sides of the equal need to be the same type. So it first sees the 1 and it thinks that this should be a false, should be a float, right? And yeah, if you want to have multiple let statements, you just, it's white space sensitive, so you need to just have a new line and have it in the same indent level. So yeah, for example, let's do something where we refer to a variable. I don't exist. And this is another kind of error that happens in the type checker. Undefined identifier, I don't exist. And the type mismatch matches. So yeah, all of this is, I think it's pretty solid. I have a tokenizer, the parser, the type checker that uses type inference. You can't define type annotations right now. And I don't have any code generation. It's basically a toString that I'm doing kind of dirty. So, I want to tie it up with code generation and be able to run the code in the REPL and in the environment. It's going to compile to JavaScript, and right now I'm using Dino to run it instead of Node, because with Dino you can compile the whole program into a single executable, so you could easily distribute it. And you can also, Dino is a JavaScript runtime, right? So if I output JavaScript, you can also run the JavaScript. And once I have the start to end compiler with the code generation and all of that, I will start adding more features. So for example, I want to add pattern matching, and I want to add type signatures, so two quite basic things. And then I want to add modules and define some basic modules from the standard library. And those are some of the basic things. And then after that, which is already a bunch of work, I'll see what follows, right? But yeah, it's been very exciting. Been using Dino and Rescript to build the compiler. It compiles the JavaScript. Maybe it will not be the most performant thing in the world, but it's a lot of fun. It's a lot of fun, and it's an intellectual challenge. Really fun to work on. And yeah, that's it. Bye.